Hi, my name is Connor Tracy, and today I'm going to be talking about turning a riboflavin binding protein into a self-sufficient monooxygenase by Cofactor Redesign. And I'm going to be talking about table number 1. Alright, so the question addressed by this paper was, the alteration of flavin structure in the binding of N-alkylated flavins to riboflavins prepare self-sufficient monooxygenases. And this would be done using cofactor redesign, taking a process that already creates artificial flavoenzymes to make peroxide-driven enantioselective sulfate oxidations. Lots of big words there. Alright, so pretty much they're asking if they can take something that already produces peroxide-driven sulfate oxidations and redo it to make it a self-sufficient monooxygenase. Alright, now to address this question, they used cofactor redesign on flavins to create artificial flavoenzymes that would be able to work as peroxide-driven monooxygenases capable of enantioselective sulfate oxidations. And they used a riboflavin binding protein from chicken to serve as the riboflavin storage protein. That way they could isolate different changes in the flavins that they needed to see. Pretty much what they were looking for was higher amounts of sulfate oxidations, just to make sure that the process was actually going and they were creating riboflavin, or they were creating self-sufficient monooxygenases. Alright, so table's flipped right there. As you could see, flavins, there's the different changes in the flavins that they used, and their overall conversion factor was between 37 and 55% total, and the yield of our sulfate oxides was between about 10 and 30%. I think there was an 8% and a 33% in there somewhere, but overall it was about 10 and 30%. Now they had 3 controls where there were either minimal changes or no change whatsoever. That was entry number 17, 18, and 19. And they all had less than 3% yield for our sulfate oxide. So overall, I think we can say that it was pretty much a success what they did. It seemed from reading the paper that they knew what they were doing and they knew that this was going to work. They were just double checking, testing to make sure it worked. Yeah. So yeah, they successfully created self-sufficient monooxygenases. According to the table, you can see the different conversion factors, the different conversion percentages, the different flavins. They used none for 18, and the rest were differences between 1 and 6. You can see the different R1 and R2s that they used, and for all this was done by employing the RFBP, or the riboflavin binding protein. So it was a success according to the table. From looking at it, you can see high percentages, exactly what they were looking for, especially a lot higher than their controls. So that's that.